Okay, today we're going to talk about right triangles. And we have three different parts to this triangle, the hypotenuse, and then we have two legs. So go ahead and draw this triangle in your notebook, and then take these three words, the hypotenuse, leg, and go ahead and see if you can label this triangle correctly. So please hit pause and label this triangle. You should have labeled the triangle like this. The two legs are connected by this right angle. The right angle is always denoted with this symbol, and the hypotenuse is always across from that right angle and is the longest side of the triangle. Today we're going to be using a formula that deals with right triangles and will help us find the missing side lengths of only right triangles. So keep in mind, as we work with this theorem called the Pythagorean theorem, we're only working with right triangles today. All right, so if you haven't gotten your toolkit out yet, you will need your toolkit. And we're going to be looking at the right triangles and the Pythagorean theorem. And you can find this toolkit entry on page 71. Go ahead and read along as I read. A right triangle is a triangle in which two shorter sides form a right 90-degree angle. Those two shorter sides, we said, are these legs. The third longest side, called the hypotenuse, is opposite the right angle, across from the right angle. The Pythagorean states that for the right angle, the sum of the squares of the lengths of the legs, so that's the length, this 3 inches, this 4 inches, and the square, so 3 squared and 4 squared. And the sum means that we're adding, is equal to the square of the length of the hypotenuse. Okay, so I said we could use this theorem to find the length of a side in a right triangle if we didn't know all the side lengths. So we're going to be finding the side length. Okay, so we took the two shorter legs, 3 and 4, and we're going to square those numbers. Now remember, when we square, that means we're multiplying the number by itself. So we get 3 times 3, which gives us 9, 4 times 4, which gives us 16, and then we add 9 plus 16, and that gives us 25. Then we have 25 equals x squared. Now, we're solving this equation, and when we solve an equation, we think about undoing operations. So if we would have addition, we would undo it by doing subtraction. If we would have multiplication, we would undo it by doing division. So here we have a x squared, and to undo it, we have to use what's called a square root. So what I'm asking is, what number times itself gives me 25? And that would be 5. So the missing side of this triangle is 5. Okay, now go to the notes section of your margin and please copy down this first example. We are looking at 6 inches and 8 inches as the two legs of this right triangle, and we are going to use the Pythagorean theorem. So it says that we take the 6 and the 8, and we are going to add them after we square them, and that should give us that third side, the hypotenuse, squared. 6 squared gives me 36. 8 squared gives me 64. That's still going to give me c squared right now. 36 plus 64 gives me 100. That equals c squared. What number times itself do we know gives me 100? So what is the square root of 100? It is 10. So the missing side of this triangle is 10. Tomorrow, we're going to take a look at the bottom portion of this toolkit entry, the converse of the Pythagorean theorem, which is at the bottom of page 71, and we're also going to take a look at example number 2.